what you see here is a BacComber system, and this system is meant for cooling water treatment, condenser water treatment, or recirculating water treatments. And what you see here is a small unit. It's good for 350 RT, right? So 350 RT is equivalent to about 200 to 250 meter cube per hour of flow rate, right? For small unit like this, come with 4 emitters. What you see here is 2 emitters here, right? So one unit come with 4 emitters, and the emitter is to be placed inside the cooling tower basins. And this represents a cooling tower basin, and it has to be submerged in the water, right? So when BacComber system emitting the ultra low frequency through the emitters and then imparting the ultra low frequency energy into the waters and do the treatments, right? So with this treatment, we are controlling 3 objectives: control scaling, control corrosion, and also control biological growth, which include bacteria, even the Legionella bacteria, and also algae. So this is, we call it the Optima unit, and this is a standard modular unit for small capacity. But if let's say your cooling towers has much bigger capacity, few thousand RT or 10,000 RT, this is the choice for big capacity. So what you see here is a customized panel, and is to cater for bigger capacity, few thousand RT and above. Okay, so what you see here is the emitters being placed inside a cooling tower basin, right? So here is a container to simulate the condition of a cooling tower basin, and simply what you need to do is just to place a pair of emitters inside or submerged into the water, right? And then you may just turn on the power. And now the emitters is actually treating the water, right? So this acts like a retention tank, and the water is being circulated, supplied from this cooling tower basin and go to the entire circuit of the system. And that's providing the effect of corrosion control, scale control, and bacterial control, right? So moving forward, what I'm going to demo to you is to provide you a full sensory experience of ultra low frequency, which you are able to see, hear, feel it, and even taste ultra low frequency, right? So now, what I'm going to demo to you is the C part of ultra low frequency. What you're seeing here, you don't see anything, but actually the emitter is working on, right? So I'm going to demo to you the C effect, right? So when I'm lowering this device, you can see that the LED light is being lit up. This means that there's energy is being transmitted into the water, right? That is the effect of lighting up the LED, which means there's electromagnetic field that is imparting into the water. So after you see it, you know there's energies in the waters. Next, what I'm going to show you is you are able to hear the ultra low frequency. So the ultra low frequency is actually a bandwidth of frequency. We are actually sweeping from a certain frequency range to another frequency range. So that's why you hear there's a various tone of the frequency. And you also can feel what is ultra low frequency. And the most direct way, intuitive way of sensing the ultra low frequency is by putting your hand into the water. And you feel the kind of tingling effect of ultra low frequency, right? Other than see, hear, feel, what is more important is that you even can taste the taste of ultra low frequency. So now, simply we use a Coca-Cola, right? We might pour out some as a control into another container, right? We pour it. So this represents the control, and put one side. And the whole bottle of it, we just submerge into this container. And the ultra low frequency is affecting onto the Coca-Cola, and we may be able to taste the difference of a treated one and an untreated one later. So just now we have introduced the BacComber system, which is a system to cater for cooling water treatment or recirculating water treatments, or you can use it for condenser water treatments. And for BacComber, that system, the objective of it is to control three things: the corrosion, the scaling, and the biological growth, which include bacteria and algae. And moving over here, you see another system, we call it LMAC. So LMAC is actually a system or a product to specifically cater for corrosion protections. And there are a few key components in this demo, right? So this is a small band scale unit. What you see here, this is the control panel, which consists of the heart of the UF that generate the ultra low frequency. And this ultra low frequency is being transmitted by these emitters here. Okay, so the emitter is to be submerged in the waters. So on the other side, there will be a test piece. So this test piece is actually a rusted test piece to stimulate the actual conditions that is submerged in the waters. So this test piece can be anything, right? It can be your pipelines, can be your submerged structures in the sea, in the fresh water. Okay, so now this test piece, we lower it down into the water, right? So before we start, we could check on the surface potentials of the test piece. And the surface potential values will tell us whether the test piece is underprotected or not underprotected, right? So we have a reference cell here. So this is actually a zinc reference cell. So before we start, we can measure the surface potential of the test piece to see whether the test piece is underprotected or not underprotected. So by now lowering down the reference cell, we are able to measure the potentials. So the measurements, we can use the multimeters, right, as you see here, and then we turn to the DC mode, okay? And the negative side, we connect to the reference cell. Whereas the positive side, you can touch on the test piece, or you can touch on the terminals that is connected with the test piece.
Okay, let's go.
So before we start, we can see the multimeter in DC mode now, the value is almost 0. So the positive terminal of the multimeter should touch on the metal piece. So now we touch on the metal piece, we will see the readings become 250 or to 260 millivolt, right? So this is when the system is before turned on. This reading means that the protection is not on yet. So when we turn on the system, we will see the reading shift more negatively. So the moment we turn on, we see that the potential drop close more than 200 millivolt. So now the test piece is being protected by our ultra low frequency system. And after some time, we will see the magnetite formations. So now you can see, after some time of UF treatment, we can see that the test piece, those portions that is submerged in the waters, has turned black. And this is actually the magnetite formations. And with this magnetite formation, as it is a dense layer, it can stop further corrosion, and it can inhibit further oxidation. So this is the magnetite layer. So now you understand BacComber system has three main objectives. That is to control scale, control corrosion, and also control bacterial growth. And after that, we show you the LMAC system, which is meant for corrosion protections. And over here, this is a system for scale control. And this system, we call it the water soft system. It's actually water softening system, right? What we are doing this is that a lot of places you have hard waters, and you cannot run your cycles for many cycles, and then you have to soften your water first. And with this system, without adding any chemicals, you can do the water softenings, right? And this is, again, is based on our ultra low frequency. What you see here is actually a bath of hard waters that is contained about 200 ppm of